15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. Thank you for joining us. This is episode 208 of the Space Nuts podcast. And I'm just looking at the label I have set for the recording of this show, and it's the Nuts Space podcast. Apparently, I do that a lot. I transpose letters in. That's bizarre. Anyway, welcome to Nuts Space. Andrew Dunkley here, and with me as always is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hello, Dunkley Andrew. Great to talk to you this morning.
Yes, it's a bit like that. I've always had this habit of doing that, and the other thing I do is I leave S's off words when I
sometimes quite important though.
Yeah. I mean, it can mess up a whole storyline if you turn a plural into a single or something like that. But anyway, that's my problem. Nothing else to worry about, really. Now, today, Fred, we are going to look at Pluto again. We've been getting a lot of data about Pluto because of the recent flyby, and that data is still being crunched, and it's coming back at a rate of, I don't know, snail's pace, which is the equivalent to the national broadband network in Australia. And what they think now is that Pluto used to be a hot world, which is interesting given the current temperature, 3 gazillion below Kelvin, zero or absolute zero, whatever. We're also going to look at the International Space Station. Now, we did talk recently about those astronauts being sent up there by a SpaceX rocket, and the first US launch in 9 years or something.
Yep.
But something even more significant is happening to the International Space Station, which I won't reveal right now, but we will get to it. And we've got a couple of questions, one reflecting on our discussions recently about alien contact, and another question about a possible cause for dark matter. But we're going to discuss that a little later. But first of all, Fred, let's visit our favourite dwarf planet. It is Pluto, and it is thought that it must have been hot at some time in its history, which sort of is counter to its current situation.
Exactly, that's right. So this is, this is a discovery that we simply could not have made or even dreamt about before the New Horizons flyby in July 2015 it was. So it's coming up for the 5th anniversary of that. It's astonishing. It seems like just yesterday.
It feels like it was only yesterday. Every time we talk about it and you say, it was 4 years ago, I'm going, no, it wasn't. Was it? Now it's 5 years. Next week it'll be 10.
It will, that's right. So watch out for that. But you will remember, because we've talked about this, excuse me, again, Andrew, got a frog in my throat there, or a Pluto in my throat, something like that. You will remember that Pluto's surface was revealed to be essentially icy, with huge solid nitrogen glaciers on it. Extraordinary place. But it's basically an ice surface, very much like, some of the moons of Saturn and Jupiter. So the evidence also seems to support the idea that underneath the ice is an ocean of liquid water. This almost standard scenario that we have with these outer worlds, these cold worlds, ice on top, water underneath, and then underneath that probably a rocky core. And so the thinking about where that water came from, or how the heat originated in order to keep the water from freezing solid. The speculation started basically immediately after the flyby, as soon as we'd seen the pictures. And the model that has really come to the fore is that the idea is that that Pluto thought that it started off. I don't know where we got Jupiter from. It's the other end of the side.
It's just up. It's just up the road, really.
Yeah, down the road. That's right. Pluto, the dwarf planet Pluto, started off as basically a frozen ice ball with rock mixed in with it, and that seems totally intuitive because it's out there in the depths of the solar system, 6 billion kilometers from the sun, and really not getting very much radiation at all. So you've got this cold icy ball, which has within it rocks, which themselves have within it radioactive elements, probably mostly uranium, but other fissile materials. And it was thought that this is the original idea regarding Pluto's ocean, that is what caused the water to melt, that as those rocks decay or the radioactive decay takes place in them, they generate enough heat to melt the ice and essentially form an ocean underneath the surface. But that has now been...
Oh, okay. No, but the thinking was that Pluto was radioactive.
That's right. And that still might be true. But there is evidence that points in the other direction now, that Pluto started hot and has cooled down rather than starting cold and has warmed up.
I see what you're saying. Yeah, okay.
So the scenario that has, and this is a newly published result. It was published just a couple of days ago in the journal Nature Geoscience. What it suggested was that the process by which Pluto was built, which was the same as all the planets and dwarf planets, this process of accretion where bits of debris essentially collide together, they stick together, sometimes they blow themselves apart, but the overall process is stuff sticking together. And that accretion process itself develops heat, because as you have bodies colliding, you get heat released from that. And so the idea is that the infant Pluto 4.6 billion years ago was hot rather than cold, and it's actually cooled. Why is this being presented as an idea? What's the evidence for that? And the evidence is that as water turns into ice, it expands. Ice is unusual in that when water freezes, it actually expands. We all know that from burst pipes.
Oh yeah,
that's how they burst.
And overfilling things that you put in the freezer.
Yeah, that's right, and all of the above. Yeah, so it expands, and the observations of Pluto's surface made by the New Horizons spacecraft revealed many cases of I suppose what you call stretch marks. These are cracks in the surface, which are caused by huge areas of ice spreading apart rather than compressing together. It would be the other way around if you had the cold start scenario. But the hot start scenario predicts that you're going to get these basically they're fault lines, which are tears in the surface almost. You're going to get those as the ice freezes and it expands. And sure enough, that's what you see. They're everywhere on Pluto's surface. So this paper, I think, is being greeted with some interest by the planetary science community. It's really... in a sense, it opens up a window on the way all the planets formed, that they all would have had a hot start, and maybe the moons of Jupiter and Saturn as well. Yeah, so it's...
So could you draw a comparison between Pluto and, say, Enceladus, which is an ice world?
I'm sure yeah, I'm sure that's true. Enceladus, perhaps the best example of those things, certainly the one that's best known because of its ice geysers near the South Pole. But Europa, probably Ganymede, Titan, they all have this same structure. So maybe, they all have a hot beginning rather than a cold one.
So what's the thinking on Pluto's interior now? Is it, do they still think it, is it just a solid ball of ice these days?
No, there would be a rocky core, Andrew, because that, early on if you do have a hot start, you get this process called differentiation, which is what pushes the heavy elements down to the center. It's basically the self-gravity of this gooey lump of rock and ice and perhaps molten metals and things of that sort. The natural process is for the heavy elements to sink to the bottom. That's why we've got an iron core in the Earth, because that's one of the heaviest elements. But it also, I think the thinking is that yes, there will be a rocky core, but that probably still does have radioactive elements inside. So there might be a bit of both, that you've got heating coming from the interior that is actually causing the ocean to stay liquid, as well as this hot start, which meant that it was liquid to start with. Clearly this is work that will develop, and people will perhaps put a few more details on the theory. But that broad outline of the theory seems to be fairly secure, given these curious long fault lines on the surface that show evidence of stretching of the surface.
So what we're basically saying, rocky core, icy surface, and liquid in between.
That's right, yeah. And probably some heat coming from the core. There would be heat, residual heat from a hot start that would be locked up mostly in the core, but there might be radioactive processes going on as well.
I have a question, and we could apply this to Enceladus, or we could apply it to Pluto. But what if you could just drag one of those worlds and put it in orbit around Earth as a moon, for example, or just put it in orbit around the sun in our proximity in the Goldilocks zone? What would happen to Pluto or Enceladus or whatever?
So you've hit the nail on the head. You're putting it in the Goldilocks zone where liquid water can exist. That's not to say that it would melt, because we know that there is ice in those deep craters of the moon where the sun never reaches. So you might well have a curious situation where on the sun-facing side of Pluto, you've got radiative temperatures high enough to melt the ice, and it freezes again on the other side. It's a really interesting scenario.
Yeah.
I wish you hadn't asked me that, Andrew, because it's kind of a slightly uncomfortable thought, this poor planet whirling around.
Well, if it ever happens, we've got bigger problems.
Yeah, we do. We've got bigger problems.
All right. Now, another fascinating discovery.
Remember that Pluto is actually smaller than the moon, quite a bit smaller.
Yeah, I kind of figured. I'm never very good at remembering dimensions, but I knew it wasn't a huge place, which is why it was sort of put down to a dwarf planet, wasn't it? That's part of the reasoning.
That's part of it, yes. It was more about the fact that it's a member of a much bigger population of objects, rather than
indeed
it's cleared them out.
Well, there'll probably be more to learn about Pluto after the New Horizons data gets crunched, because they're continuing to go through it. And as we have mentioned a few times, it's a slow process to work your way through all that information. So what else are we going to learn about Pluto? I think it's very exciting. It's a favourite little world, even though it's no longer considered a full-blown planet, but who cares? I mean, it's the discovery of it was exciting, and we're still out there looking for other worlds as well. This is Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Just a shout out to our supporters to thank you for putting a bit of money into our podcast to keep the bills paid and the lights on. And you can do that a number of ways these days. You can do it through Supercast. That's spacenuts.supercast.tech. And we've got a $5 a month offer there for anybody who wants to become a supporter of Space Nuts. That you can do a 30-day free trial through Supercast, and then once you've signed up, you get full access to the back catalogue, weekly episodes, bonus material, and it's 100% commercial free. That's an option for you. We also have a lot of supporters through Patreon. Space Nuts we've been on Patreon longer than anywhere else, and so we've got quite a few people who support us. It's only a few dollars a month. We're not asking for big bucks. We're not asking for any. It's optional. You get to choose. But patreon.com/spacenuts. And you can also support us through our distributor, Acast. So you might want to check that out through our website. But thank you for supporting the Space Nuts podcast. And by the way, the bonus material comes in the form of questions from our patrons. So if you are a patron and you've got a question you'd like to send to us, make sure you identify yourself as a patron, although our producer Hugh probably knows who you are and will be able to let us know either way. But we would like to see if we can get some more bonus material out there for you as a supporter of the Space Nuts podcast. Now, Fred, to this interesting story about the International Space Station. Now, we reflected on the launch of a SpaceX rocket recently that took 2 astronauts to the International Space Station, the first launch from American soil for such a purpose in 9 years. But now the International Space Station's in the news for a much more critical reason. To use the Australian vernacular, they're getting a new dunny. And for those who are going, a what? A toilet. They're getting a toilet. This, I imagine, will be something that you could get at your local hardware store for about $100.
In your dreams, Andrew. What they're getting is something called the UWMS. Which is,
it sounds too scary.
It's the Universal Waste Management System, and it basically is a prototype for the kind of technology that will be needed for flights to, for example, Mars, where you've got really long missions in space, and where you've got to cope with what you generate in terms of human waste. And so what's happened is that perhaps the most inconvenient parts of the convenience on the space station at the moment, they are being designed out. And so the idea is to make the system as smooth and as streamlined and as easy to use and as foolproof as possible, which apparently the current one isn't. I think they're quite difficult to use, especially if you happen to be...
You don't really want to be in 0G and turn to someone and say, how do I use this thing again? What's this button for? Yeah. That would not be ideal.
It's a bit late by the time you get to that. So yes, so the system that's used on the International Space Station is adequate, but like Space Nuts, it's adequate but could do with improvement. So so what's happened is a new design has been evolved, which apparently is based more on its structure on the Russian design, because there's a separate Russian toilet and a separate American toilet. I'm sure they can use both, but they've got slightly different technology in the way that you support yourself on the seat. So it's following more of the Russian design. So this the design has evolved, and with an eye on future waste disposal requirements for longer space flight. And what's happening is that a prototype is being sent to the International Space Station so it can be tried out in weightless conditions, because the last thing you want to do is build one, put it on a Mars flight, and then discover, when you've just left Earth orbit, that the thing doesn't work very well and you've got plumbing problems, which we're all familiar with.
You've got space doogies all over the place. That's the big danger.
I knew you'd get that into it somewhere. Never mind.
I had to.
Yeah, you had to.
I think the most disturbing part of this story is it's featured on the space.com website, and they actually quite literally have a video of you getting down into the bowels of a space toilet. I mean, it doesn't get much lower than that. It's perfect for us, but it doesn't get much lower than that.
That's right. It's look, it's very basic stuff. It's all part of the human condition, and we're all gifted with this facility to produce waste. So you've got to deal with it. What surprised me, Andrew, was the estimate that this is a quote from one of the NASA officials who's involved with this. Is actually Deputy Program Manager for Environmental Control and Life Support Technology and Crew Health and Performance at the Johnson Space Center. He made the comment that current estimates suggest that Mars missions would need to manage about 270 kilograms of solid waste, about 75% of which is water. So it's a quarter of a ton more, actually, for for a Mars mission, and that's probably just a one-way flight. You've got to do the same on the way back, I would guess. It's not a trivial problem, and that's really why this is being done, to check out what new technologies you can involve yourself with.
It's also very handy if you get stuck on Mars and have to grow potatoes to survive until a rescue mission can be mounted. I've heard.
I've heard that too, but I'm not sure whether I believe it.
Feasible, but possibly not absolutely possible. Yeah. But all jokes aside, it is one of the big issues facing long-haul travel in space. What do you do with the waste? How do you process it? Where do you put it? How do you get it where it needs to go in the most convenient fashion without causing too many problems? And I was surprised that you said there were different toilets for the Russians and the other astronauts.
Just the design. I think it's the design of I don't think it's a segregated toilet. I think it's that the toilet on the Russian side of the space station. Apparently, it's about the way you support yourself. On the Russian side, the astronauts hook their feet into tow bars, whereas the American equivalent on the US side, you use thigh bars to anchor yourself in the weightless environment. Work that one out.
Does it require some sort of vacuum effect? Because otherwise, I think you could be running into trouble if you're relying on gravity.
There is indeed exactly that, a vacuum system. But the thing that always entertains me, there is a fan in there as well, or a device that actually fragments the bits and pieces, if I can put it that way, which, yes, it has echoes of a well-known phrase or saying, doesn't it, really?
Yes. Yes, and I think this show just hit the fan itself.
It did, yes.
I'm pretty sure. But if you want to see the device, the Universal Waste Management System in operation, they are featuring it on the space.com website. And it is a really complicated thing. It's not a simple process. And I imagine they dedicate a little bit of time to training astronauts in the proper use of it because, as you say, they don't want to be up there and suddenly go, how do I do this again? What? Quick. Tell me quick. Oh, horrible stuff. You're listening. I think we've done enough on that. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
3, 2, 1.
Space Nuts.
Now, just before we tackle some audience questions, we've got 2 audio questions today. A reminder that you can ask an audio question if you've got a device with a microphone. It's as simple as that, whether it's a desktop, laptop, or handheld device like a smartphone or a tablet or something. You can log on to our website, spacenutspodcast.com, and you'll see a bunch of little tabs up the top. There's one that's labelled AMA. That's where you go to record your questions for us, AMA. And I would encourage anyone who has a question for Fred to do so. You don't have to do it by voice if that makes you too nervous. It certainly freaks me out. You can send us a question in the traditional form using letters and numbers on paper. Or by email, whatever works for you. But that's the way we do it. Now, Fred, our first question comes from Carrie in Sydney.
Hi, this is Carrie B from Sydney, Australia. I've just been listening to episode 207, and we were talking about what we would ask aliens if they visited us. And one thing I've wondered in the past is, would aliens be like us in that they could detect the same things we can? Like, what can we detect apart from molecules, electromagnetic radiation, magnetism, and I'm not even sure what that is, but some animals apparently can do that. Just as planetary organisms, what can we detect? Like, what's our limit? And could someone from somewhere else in the universe be programmed to detect other things? They might be in the whole dark energy, dark matter zone, and maybe they can't detect photons, or I don't know, they can't sit on a rock. Is that possible that could be the case? Thank you. I love the show.
Thank you, Carrie. Nice to hear your voice. I've seen you pop up on Facebook many times, so lovely to hear from you. And I think you and Carrie have met at one stage, Fred, have you not?
Oh, I believe so. Yes, that's right.
Yes. I think Carrie's an uber fan of yours. Now, she asked some interesting questions. What can we detect? What could aliens detect? Could they be in a situation where they can't sit on a rock and look out into space and detect much? I suppose it depends on how they've evolved and what sort of technologies they've developed. But maybe we can break it down and discuss what potential there is for intelligent life beyond us to detect us or detect other intelligent life forms. What do they look for? How do they look for it? And I think from our point of view, the way we do it could be a good starting point, Fred.
Yeah, so I guess you're right that this is a question that needs breaking down a bit, because we have 5 natural senses, but we also have instruments that can detect other phenomena. That's because we've evolved as a technological civilization. I guess if you're talking about aliens and what their senses might be, and I think that's really the gist of Carrie's question. That's a really interesting question, whether their senses will be different. And Carrie's right in suggesting that some animals can detect magnetism, because we know that migrating birds have a structure behind their beaks that actually allows them to sense the magnetic field that they're flying through. It's extraordinary stuff.
And I think they're starting to realise that some of the issues facing whales that beach themselves might have something to do with Earth's magnetic field. At the very least, it could be a disturbance in their sonic array. We're starting to pick up on all of these elements of different species on Earth and how they use their bodily functions to get around. So it's an interesting situation.
So you could imagine, we've got the 5 senses, and when we touch a surface, we touch a surface, and it's only by the feel of it that we get an idea of what it might be. But just imagine if you had a species which was able to analyze the molecular structure of the surface that it's touching, exactly as Carrie suggests there. Very, very interesting thought that you don't only need to touch it and say, yeah, this is aluminium, or this is a piece of steel, or this is a meat pie. It opens up a whole range of different possibilities. And I'm sure, touching on an area that you're very fond of, Andrew, I'm sure that science fiction authors have actually speculated on this idea, because science fiction authors have speculated on just about everything. So there might well be books or short stories that.
Funny you should mention that, because in this new book that's out by some unknown author, the Turanian Enigma, one of the life forms in that has developed the capacity to see quite naturally across all light waves.
Well, there you go. Yeah. So that's right. So it's it's an extension perhaps of what we can sense in our innate form of senses, rather than anything we can detect with instruments, because clearly we can detect radioactivity and all kinds of other things that we can't pick up by our 5 senses. I do like the idea that Carrie proposed, though, as well, about dark energy, dark matter. It may well be that if you had dark matter is interesting, because it may, and I think we're going to talk about that again in a minute, but it may be that it's not just one species of subatomic particle. There may be a whole atomic structure, a whole dark matter periodic table, if you like, that could give rise to perhaps dark matter structures, maybe even dark matter living organisms. That's speculating way beyond our present knowledge, but it's an interesting thought. The only thing is, if we had dark matter aliens, because dark matter doesn't interact at all with normal matter, how would we find them? Or how would they find us? Well, they might have senses that would let them do that. Yep, it's a great question, and thank you very much.
Yeah. And of course, you and I have talked about the future telescopes that will be analysing planets beyond our solar system for signs of life, and they will do that through spectrum analysis. And I suppose what we'd be looking for as a species is gases or telltale signs in the atmosphere of another world that could indicate industrialization or something along those lines. Those are the kinds of things we're going to be looking for in the future.
That's right. What are being badged as technomarkers. So biomarkers are things that in an atmosphere, for example, that give an indication that there are life processes there, because you're looking at things that don't occur in any other way. And technomarkers would be revealing some sort of technological prowess, because you're producing molecules that are not actually produced by natural processes. It's all still a little bit hairy around the edges, this stuff, but it is very much the way future astrobiology proposals are being couched. So the big telescopes will, as you say, be looking at analysing the atmospheres of planets, extrasolar planets, and who knows what we might find there. I hope you and I get to talk about it, Andrew.
I hope so too. I hope they find something extraordinary. I really do, because that's what we're all hoping for. That's why they're doing this. We want to make some extraordinary discovery about another world beyond us, and then all feel disappointed that we've found life and we'll never see each other because it's too far away. But it would be an amazing thing to say we've found a planet that has industry. Yeah. That in itself would be just beyond the imagination. Carrie, thank you for the question. Really good one to discuss. Hopefully we hit one or two of the nails for you today. Now let's move on to our second question. This is from Roger, who's driving his truck.
Hey there, Space Nuts. My name is Roger. I'm a truck driver driving around the northeastern part of the United States. Found your podcast, really enjoy it. You guys rode along with me for quite a few miles here, and I appreciate that. But just wanted to put out an idea about dark matter. What if it has something to do with quantum entanglement? Or say two photons of light that are entangled leave a star, and what happens to one affects the other, and one of the photons was to fall into a black hole where it's subjected to huge amounts of gravitational force. And what if some of that gravitational force is transferred to the other photon, where it doesn't change its mass, but it makes its gravitational pull on objects around it greater, kind of masking it as something more massive than it is? I think it'd be kind of neat to find out that dark matter is because of a black hole. But anyway, love the podcast. You guys keep on trucking.
I love that. I don't think we've ever been hooted before, Fred.
No, it's great stuff. I like that too.
Now, Roger brings up an interesting point, and it does sort of it's sort of tickled a little memory in my brain about a discussion we did once have about photons in pairs and black holes, but it must have been a while ago, but I do believe we have touched on that subject.
Thanks, Andrew. I'm very glad you said that, because I had the same tickling in my brain as well. I'm sure we've talked about this before. And I think what I said at the time, and I'm saying it again now because it still applies, this is a really interesting idea. If you have two entangled particles, which are at a distance from each other. So quantum entanglement, just to fill in the gap, is when you've got two, let's say, subatomic particles, because they usually are, which are in the same quantum state. They're sort of bound together by quantum physics, so they behave as though they are one particle. But if you separate them by a long distance, they still behave as though they're one particle. And so if you do something to one, the other one reacts, no matter how far away it is. It's an extraordinary phenomenon that I think still is not really terribly well understood. So the question that I recall that we were talking about before, and it has echoes of what Roger's asking about, is, okay, so you've got two entangled particles, whether they're photons or protons or whatever, probably doesn't matter. And one of them falls in through the event horizon of a black hole. So it crosses the event horizon. It's sort of got echoes of the way Hawking radiation works, Andrew. Hawking radiation, that idea that black holes can actually radiate energy at very, very low rates, proposed by Stephen Hawking back in the 70s. It's what really made him famous. And the idea is that you have virtual particles coming into existence in space. That's believed to be the case, that they pop in and out of existence, these virtual pairs. And if one of a virtual particle pair falls into the event horizon, then the other one's basically left to radiate into space. So you've got essentially this Hawking radiation. But that my knowledge of how that would react if you have two entangled particles and one falls into the black hole, that's the limits of my knowledge of this. And I'm pretty sure what I said last time we talked about this was, I'll ask one of the pundits about how this works. And I haven't done it, but it's a really interesting question. And I will try and follow up on that. What happens when entangled particles, when one of an entangled pair falls into the event horizon of a black hole? I suspect it is not likely to relate to dark matter or dark energy, because there are some very clever people out there who probably would have already thought of this. But it would have interesting consequences, and I'm really not sure what they are. So thanks again, Roger. I'll do my best to look into it, but it won't be this week because I'm flat out. But I will do it soon.
Fair enough. I would, from a layman's point of view, wonder if the particles are entangled, that both of them would have to go into the black hole, or is that just
that's the
basic
thing, because these things can exist. So they have to be in this, what we call a state of quantum superposition, which means they essentially don't interact with their environment at all. Otherwise, they lose that quantum superposition and they behave just like normal particles. So that's the first problem with this. But if they are entangled, you can separate them by large distances. You can probably drop one of them into the black hole. And my suspicion is that when one of the particles crosses the event horizon, this is a blind guess, but this is what I think is most likely to happen. That interaction with the black hole at the event horizon essentially spoils the quantum entanglement. It means that they are no longer in a state of quantum superposition. They've returned to being normal particles. And so nothing happens, essentially. You've just got one particle left outside. And I guess in a sense it becomes akin to Hawking radiation. Because the quantum state that things are in, this peculiar state of superposition where it can be in two places at the same time or have two different characteristics simultaneously, that is highly dependent on it not interacting with its surroundings. And that actually is the big hold-up with quantum computing. You can't, how do you make these quantum particles that you're trying to use for quantum computing, how do you keep them in that isolated state while you're still interrogating them to find out which way up they are or whatever? It's as soon as you interact, you lose the quantum state. And that's my guess, that would be what would happen. But I'll check on that. Yeah.
Yeah. Wow. Yeah, you brought up quantum computing. That's another thing they're trying to crack. If they can ever crack the science behind quantum computers, the world will just be a completely different place. They'll have these computers that are operating at super high speed with massive amounts of memory, and who knows what we'll be able to achieve when they perfect that. I know they're working on it and they've cracked a few puzzles, but I don't think they're there yet, are they?
Not in terms of a commercial, useful computer. There are quantum computers, but they're very much experimental. They're things that can only work in a lab and have limited capabilities. But eventually we might have commercial quantum computers, and then who knows what we'll achieve.
Oh, good grief! Yeah. Well, when you consider that a standard smartphone now is how many hundred times more powerful than the computer on Apollo 11?
Yeah, that's right.
Once we get to quantum computing, all bets are off. It's just going to be crazy town. And I think for a good reason, not a bad reason. I think it's probably a good thing for humanity because it could solve so many problems. Yeah. You've also got to consider that there will be a negative side to it, but that's the case with computing and smart machinery now. There's always a dark side, and that's where dark matter comes from. See, I just solved it.
Well done. You and Roger, between you, you've done it.
Thank you, Roger. Appreciate the question and appreciate the toot. That was lovely. We're going to have to wrap it up, Fred. That's it for another show.
Thank you very much, Andrew. It's been a great experience again, talking to you and trying to figure out what's going on in the universe while I do. Thank you very much for...
We're also trying to figure out what's going on in space toilets. So thank you for giving me the opportunity to discuss space doogies once more.
Yeah.
Appreciate it.
Never miss an opportunity.
Dear. Thank you, Fred. We'll talk to you again real soon.
Sounds good. Take care, Andrew. All the best.
That's Professor Fred Watson, Astronomer-at-Large, the better half of the Space Nuts podcast. And from me, Andrew Dunkley, thanks again. Don't forget to visit the Space Nuts website. It's spacenutspodcast.com. You can ask your questions through the audio interface there on the AMA tab. And don't forget to check out the Space Nuts shop. There's Astronomy Daily. There's all sorts of things. There's even a special tab for books. Good grief. We've got our own tab, Fred. Amazing. Until next time, thank you for listening to Space Nuts. See you soon.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.